In the last section, we had a long discussion about the layout of our application as it stands right now. However, we didn't really get that much closer to write any code to get our box to actually center up on the screen. So to get our box to center on the screen, we're not going to actually change the box one bit. Instead, we're going to change the cat. So let's talk about exactly what we're going to do here and why we're going to do it. So the first thing I want to remind you is that at present, if we find our build cat animation method, that cat is being moved around on the screen through the use of a container. We have our container being created inside of our builder method, and on the margin property of the container, we are trying to change that margin on the top, and that is what is causing the box to move, or excuse me, the cat to move around. Now there's a very big downside to this approach now that we're using the stack widget. Let me show you what that downside is. Okay, so back inside over here, I'm going to just click on the cat, and that's going to start our animation playing. And you'll notice that when the animation plays, the box actually moves as well. So let's think about what's happening right now. Back inside the stack class documentation, I want you to recall the stack is going to try to contain everything inside of it, and it's going to resize itself to contain everything inside. And so when we start to increase the margin of the container that is being displayed inside the stack, this margin right here is causing the container to increase in its overall size. And so we can now imagine that we are in a situation where we've got the image like down here, and the image has a ton of margin. Here, I'll put another thing right here. I'll call it margin, and it's got a ton of margin right above it. And so in total, the image is trying to take up this much height. Of course, the box, or the stack, the green thing right here, is going to try to resize its height to fit the total height of the image plus the margin above it. And so the stack starts to grow, and at all times our container is going to try to stick to that upper left-hand corner. And so essentially we can imagine that the margin starts off as very low when the animation first starts, so the container is like down there, and the margin starts to grow. The stack grows to match it, and so the margin keeps going, the stack keeps going up, and as both those change and the stack starts to increase in size, the container stays pinned to the top left-hand side. And so that's why we are seeing the container move around when the cat animation plays. So like I said, we're going to fix this not by changing the box, because the box is essentially doing the right thing. You know, it's moving around as we want it to do. We're going to instead fix it by changing the cat. And we're going to make the cat not affect the overall dimensions of our stack. That's the key. We don't want to change the dimensions of the stack, because if we change the dimensions of the stack, that's going to cause everything inside of it to move around. So in order to keep the cat from changing dimensions of the stack, all we have to do is turn the cat widget from a non-positioned widget into a positioned widget instead. When a widget is positioned inside the stack is not going to consider that position widget when it is trying to size itself. Okay, so that's the idea. We're going to find our cat right here. Rather than using a container, we're going to do something else to it to make it a positioned widget instead. So how do we make a position widget? Well, we just use this position class, that's it. So we're going to look up the documentation for positioned. The position widget is essentially a container that is specifically used inside of a stack. So we only use positioned when we are inside of a stack. And even the first sentence right here, only use position when it's a descendant of the stack. The position class is used to apply just a tiny little adjustment on the positioning of some widget inside the stack. You'll recall that when we were talking about our diagram back over here and initially saying, oh yeah, we want to use a stack because we want everything to be rendered on top of each other, we then said we're going to render everything on top of each other and then kind of like do little adjustments to get this flap to show up here, this flap to show up over here, and the cat to show up here. And so we're going to do those tiny little adjustments by using that positioned class. So we're going to use this to kind of very slightly move stuff around. Okay, so essentially to fix all this layout stuff, all we have to do is say, rather than using a container to position our cat, we're going to use a positioned class instead. So inside of build cat animation, I'm going to find where we make our container, and I'm going to replace it with positioned, like so. Now, a position widget does not have any margin assigned to it. If we go back over to the position documentation and then look at the constructor right here, when we create a positioned element, we can pass in essentially like left spacing, top, right, and bottom spacing as well. And so that's what we're going to do to apply some movement to our cat. We're just going to change either the top or bottom positioning to kind of move it up and down the screen. So let's try doing that right now. I'll say that rather than trying to define a margin, so I'm going to delete that entire line, I'm going to replace it with, we can either do top or bottom. I don't know. Let's do bottom, what the heck. I'll say bottom. We're going to have an animation dot value, or excuse me, cat animation dot value, like so. So now whenever our animation updates, we're going to rebuild positioned. It's going to have a new essentially offset of bottom, and this thing is going to position itself relative to the stack without attempting to change the dimensions of the stack. So let's now save this and we'll do another quick test. So I'll do my refresh. Now remember, the other thing to keep in mind here is now that we're using positioned, the stack is not going to care about that cat one bit. So when we refresh right here, I see my box, but you'll notice that now it looks like the cat is not showing up at all. Okay, well, looks like we just traded one issue for another. So let's take another quick pause. We are going down the right path, I'll tell you that. We just have to add in one other little piece of code. So let's take a quick pause. We'll come back to the next section. We'll talk about why adding in position right here in place of container caused the image to essentially disappear. And we'll talk about how we're going to fix it as well. So quick break, and I'll see you in just a minute. In the last section, we refactored our build cat animation container over to a positioned element. But when we did so, it appears that the cat is no longer showing up on the screen of our device. So in this section, we're going to dive really deep and figure out exactly what is going wrong here. Now to get started, I'm going to make a tiny little code change inside of our build method. And as soon as we do, you might start to have a better idea of what's going on. So inside of build, I'm going to find my stack children. Remember that we had said the order in which we define the children inside of this list defines the order of what shows up on top of the other element. So the box is later on inside the list, so the box currently is showing up on top of the cat animation. Let's try changing that order and then saving and refreshing and just seeing what happens. So now the cat is going to try to show up on top of the box. Now I'm going to save that. I'm going to do a refresh and we'll just see what happens. Okay, so that looks pretty strange. Hopefully you're seeing something like that right there. So what you're seeing right there is the left whiskers of the cat. And I know this coloring, it's black on black, it's really hard to see, but essentially what we are seeing right here are the left whiskers of the cat. So clearly something is really bonkers right now. Let's talk about how this positioned widget right here works and get a better idea of why we are seeing what we're seeing. Okay, so like we just said, when we're looking at positioned, when we are using a positioned widget, and if we go back over to the stack class really quickly, when we're using a position widget, the stack ignores that thing when it's trying to decide its sizing. So with that in mind, we can go back over to this diagram again. So here's our stack. The stack goes on to the very center of center. We then put our container in the stack, and the container tries to constrain or shrink down just to fit that container. So the stack says, I just want to be as big as the container. And again, technically it's like right on top of it, like pixel perfect. I'm just adding a little bit of spacing in there so we can kind of get a sense of the layout. So the next thing that gets rendered inside of that stack after the box is now the cat animation. And the cat animation shows a positioned widget with a bottom of cat animation.value. So right now, let's just ignore what the image does. Let's just talk about what position does with this bottom property. So when we assign a bottom, this thing initially starts off with a cat animation.value value of 0. Remember, that's what everything begins at. When we assign a positioned with a bottom of 0, that's essentially trying to fix the bottom edge of the positioned element 0 pixels off the bottom of the stack. So we can imagine here's the stack in green, here's this new positioned element. Let's imagine that the positioned element is like this big. The positioned element is going to not try to position itself at the top left of the stack, as is the normal default. Instead, it's going to go to the top left, as is the default, and then it's going to apply that bottom constraint of 0 pixels. And so essentially the position element is going to say, I'm going to try to get my bottom edge 0 pixels away from the bottom edge of the stack. And so there's the stack right there. They're going to line up those bottom edges like so. And that's what we end up with. So again, we get the position element. It's of some mystery size we don't really know. It first starts off on the top left, as is typical inside of stack, because that's the default location, the top left. And then position says, I want a bottom of 0 pixels. And so it's going to try to offset against the stack by 0 pixels like so. And so it ends up right like that. Okay, so that explains why we are seeing kind of like just, the bottom left of the cat, as opposed to like not the top left that you might expect over here. That's why we're seeing just down over here. So now the next interesting thing is how large the cat image is. So remember before I had said that when we place an image on our screen, the image is going to try to expand to take up as much space as possible as soon as it hits either its limit of the width or the height. And so when we first put our image in, it was something like that, and it was trying to fill up the entire span of the available space of the window. However, when we use a position widget, that rule goes out the window. When we use a positioned widget, position says, hey, you know what? If you want to show something inside me, go ahead. I have all the space in the world. The position widget tricks everything inside of it to thinking that it has all the space in the world available. So we render the image inside of the positioned element, and the position element tricks the image and it says, hey image, you can be as big as you want to be. And so the image grows to be really, really big, as large as it possibly can be inside of the position widget. And that's why it appears that it is so large inside of here. So that's kind of strange thing number 2. So strange thing number 1 was why we were seeing the bottom left corner. Strange thing number 2 is why the image is so large. Strange thing number 3, and this is the really interesting one, is why we are only seeing the whiskers right here and why we don't see the rest of the cat. Okay, so that last thing, strange thing number 3, whenever we use a stack widget, by default, it's going to try to only show stuff that eventually ends up inside of its viewport. And essentially, it's going to delete or erase or not show anything that tries to expand outside of the dimensions of the stack. So even though we've got the position widget and the image, something like so, the stack says, hey, you know what? I see image that you are exceeding my bounds. I don't care for that. Image, I'm going to clip you, and I'm not going to show any extent of you that exceeds outside of my own bounds. And so that's why we're only seeing this kind of like bottom left, and it appears to cut off on the right-hand side and the top-hand side. Again, the stack is saying, get out of here, I don't care about you, I know you probably want to show something above me and to the right, but I'm not going to show anything that's trying to show up outside of my own extent. All right, so 3 reasons why we're seeing what we're seeing. So hopefully that makes a little bit more sense, and we've got a little bit better idea of how position is working. Let's take another quick pause. When we come back in the next section, we're going to make a little change to the position widget to get this thing to be properly constrained within our stack, essentially like so. So quick pause, and I'll see you in just a minute. In the last section, we had another long discussion to figure out why we're seeing this weird stuff over here. So in this section, we're going to make a tiny little change to our position widget that's going to get our image to fit up very nicely inside of our stack. Essentially something like so. Okay, so to get started, we're going to look at our position widget. Remember that just in the last section, I had said that by adding on this bottom property on position right here, that essentially is telling that position widget to try to match up against the bottom edge of the stack. And so the position widget first goes to the left-hand side, and then it says, okay, I'm going to try to like fit in just ever so perfectly on your bottom edge stack, like so. So to fix the position widget, we're going to apply 2 additional constraints on this thing as well. Besides bottom, we're also going to add in a right of 0.0 and a left of 0.0 as well. And so by adding in these additional constraints, we're going to go right here, default position the widget at the top left corner, matching up on the stack. The bottom of 0 is going to pull it up to match on the very bottom edge of the stack. Then the right of 0 is going to shrink down, or really kind of drag over the positioned to match up against the right-hand edge of the stack as well. But then by also adding on left, this is not going to allow the positioned element to just move itself. By adding on both right and left, it's going to cause the positioned element to try to shrink itself down. So the position element is now going to try to kind of shrink down like so. And so we're now saying we want you to have a 0 pixel offset from the stack, a 0 pixel offset on the right, and a 0 pixel offset on the left. And so adding on all 3 of those values essentially constrains the position element to be just this large. Now the result of that is that when the position element now tries to show the image inside of it, the position element is no longer going to try to trick the image into thinking that it can be as large as it possibly can. Instead, the position element is going to say, hey image, I'm really sorry about this, but I can only be as large as the stack. So why don't you just try to fill up the stack and be happy with what you get? And so we're going to end up with something like this right here. Again, the position element is going to be on the left, bottom, and right. And so the image is going to put it in here, and it's going to try to fill up the entire extent of positioned while not exceeding the edges and still maintaining its same aspect ratio. Okay, so that's what's happening in theory. Now that we've got right and left on there, let's do another quick refresh. Try this thing out again. And there we go. Exactly what we expected to see. So we've got the position element that's trying to fill up essentially like the left-hand side. It's trying to marry onto the bottom and the right-hand side. And then inside the space available, it's saying, okay, image, this is what I got for you. And so that's why we see the image appear on the very bottom edge of that stack, or what appears to be the container. Okay, so that's it. We've got a better idea of how all the positioning stuff is working now, and I think that this is looking pretty reasonable. Now, of course, we can still click on this, and we'll see the cat move around, which is great. But we definitely still have a little bit of tweaking to make sure that the cat kind of, is peeking out on the very top. We want it to just kind of peek, and then when we tap on it, we want it to go all the way out. So still a little bit of learning there. So let's take another quick pause, and we'll continue in the next section. We've now had a couple of very long lectures, but I think we've got a better idea of what's going on with all this positioned and layout stuff. So let's now kind of turn our focus back onto actually progressing this application. At present, we've got our cat showing up on the very bottom of the box, but as you well know, we really want the cat to be towards the top instead. So let's think about how we can fix this. One thing we could do is, rather than telling the position element right here to try to get 0 pixels away from the bottom element or the bottom edge of the stack, we could instead tell it to be 0 pixels away from the top. So now if we go back over to this layout right here, we're going to take our position element, which starts off as, who knows how large. It's going to try to go to the top left. We then tell it to marry up against 0 pixels from the top, so it kind of stays where it is. We then tell it to get 0 pixels away from the right, so it kind of slides over to the right like so. And then we say 0 pixels from the left, and so it then shrinks itself down to conform to just the space inside of the stack like so. We then put the image inside that, and the position element says to the image, remember it says essentially, hey, sorry, but this is all the space I have available. So we'll end up with something like so. So at least the cat, even though it will not exceed the extents of the box, so we won't see the ears peeking out, it will at least be towards the top of that position widget. Okay, so back over here, I've already changed it from bottom to top. So now by default, position is going to start off 0 pixels away from the top of the stack. So let's do another save. another refresh, and then back over here. When it kicks in, we see the cat at the top. Perfect. So now the next thing we need to do is make sure that the cat starts off not inside the box, but kind of like with its ears somewhat poking out. So to change that, we can really just kind of massage the value of top right here. If we add on some amount of top besides 0, then remember we can kind of read top right here as being like an offset against the edge of the containing element, which is the stack. So if we start off with a value besides 0 right here, it's going to essentially try to like push this thing down some number of pixels, really the position element down some number of pixels, or it will try to kind of push it up some number of pixels instead. Now our cat animation's value is controlled by our tween right here, and that's why we are starting off with a value of 0. So let's try changing that to something like, I don't know, 20. So now we're going to have an offset of 20 pixels against the top edge of the stack. So now with 20, I'll do another refresh, and we'll just see what happens. So now you'll notice that we're essentially 20 pixels down from the top edge. We definitely don't want to be lower. We want the cat to kind of like stick up out of the top edge. So let's try doing something like -20 instead. And actually, you know, let's be a little bit generous here. Let's do like -50. Kind of get through this a bit quicker. So now with -50, we should be 50 pixels on the other side of the top edge of the stack. Okay, so that's a little bit better. So now the cat is kind of shifted up 50 pixels against the top edge of our stack. But you'll notice that the cat is still being cut off like it was before, when we had the cat really large spanning off the side. So by default, the stack tries to kind of cut the edge of itself, and it won't allow anything inside the stack to show outside of itself. So let's take another quick pause, and we'll figure out how to change that behavior in the next section. In the last section, we managed to get our cat to kind of stick up out of the box, but it's clear that the stack is somehow cutting or clipping the edge of the cat. So again, we've said it several times, anytime an element is extending beyond the bounds of the stack, if it is a position element, the stack is going to essentially clip it. And so we would only see this little part right here. Everything outside the stack would be invisible. So in order to fix this, we're going to go look at our stack class documentation very quickly. So we'll go down, down, down to the constructor. Inside of here, you'll notice that there is an overflow property. By default, overflow is set to a value of overflow.clip. And I bet you can guess what overflow.clip does. It's going to try to clip anything that extends outside of the stack. So in order to change that behavior, we'll look at the documentation for overflow. So I'm going to click on overflow right there. Overflow is an enum, very similar to the animation status types that we were looking before. So inside of overflow enum, we can either clip, we can look at all the different values that are available inside the enum, not useful for what we're doing, and we can also just do visible. So if we do visible, we'll say that anything that is extending beyond the bounds of the stack is going to be visible on the screen. Definitely what we want. So back over inside of our build method, I'm going to find my stack. Next to children, I'm going to add on an overflow property, and to that I'm going to assign overflow.visible, like so. So we'll do a save, we'll do a refresh, and now we should see the ears of the cat kind of extending outside. There we go, much better. Now if we click on this thing, you'll notice that the cat still goes down towards the bottom. So at present, we've got the tween up here with a begin of -50, and then that increases to 100. So remember, our animation value is now being used to specify the offset from this top edge. So we start off at -50, and we then increase the offset to 100. And so we're essentially saying, take the cat and shove it down 100 pixels off this top edge. So if we want the cat to instead go up rather than down, we can use a negative end value rather than a positive one. Remember, our cat animation value right here, the animation has no idea what it's being used for. All the cat animation knows about is that it's some number that's going to change over time. And so if it suits you and me to change these values right here to better suit our animation, great, let's do it. we can change this 100 value right here to be whatever we want. So rather than saying 100, we're going to use a slightly more negative number. Let's try something like negative 90. And so now we're going to start off with an offset of negative 50 pixels from the edge of our stack to the top edge of our image. And then over time, or over 2 seconds, we're going to increase that change to negative 90. And so there's going to be 90 pixels from the top edge of the stack to the top edge of the image instead. So as usual, another refresh. There's our cat. It's negative 50 pixels off. I'm going to click the thing, and then it goes to negative 90 pixels up. Now at that point, the cat is way too much out of the box, so let's do a little bit of like fine tuning here. We'll come back to the next section and we'll get some like ending values for where the cat should begin and where it should end. So quick pause and I'll see you in just a minute. Our animation is now looking pretty good, but the range of values that our tween changes between are a little bit strange. So I think that right now the cat starts off a little bit too high, so maybe our beginning value is too negative, and then definitely at the very end of the tween, the cat is way too far out of the box. And so negative 90 right here is also way too large. Now I did a little bit of playing around, and personally I think that using values of negative 35 to negative 80 work out pretty well. So if you do negative 35 to negative 80, and then before we test that out, one other quick thing, if we go back down to our build method, I'm going to change the order of the box and the cat animation back again, so that now the cat animation is displayed behind the box. So let's save that. We'll do a quick test here. And we'll see how those new tween begin and end values work. Okay, so the starting position there, that looks pretty good. And then when we click on it, the cat comes out a pretty reasonable amount. So far enough that we can see the whole cat, but not so far that we can see like underneath the cat as well. Now, last thing I want to change here, when we click on the cat, the animation is playing over a duration of 2 seconds, which definitely feels like it is way too slow. So that's a real, I don't know, that's not a very fun animation right now. So back up inside of our init state method, you'll recall that we created our animation controller, which controls the duration over which we are changing our animation. So I think that rather than using 2 seconds right here, let's try designating milliseconds instead, and we'll use 200 milliseconds. So that's essentially 1/5 of a second. So let's save that and do another quick test. So now we'll do our click, and that's a lot more responsive. It feels a lot better than it did before. Okay, so I think that we're looking pretty good. Let's continue in the next section, and we're now going to start to move on to the next big thing inside this application, which is to design those 2 flaps that are going to be off to the left and the right hand sides of the screen. So quick pause, and I'll see you in just a minute. Our cat is now in a pretty good spot. It's inside the box, and then when we click on the box, we see it peek out and go back in. Now that we've got the cat in a pretty good location, we're going to start to turn our attention to the flaps on the left-hand side and right-hand sides of the box. So remember, the idea here behind those little flaps, looking back at the CodePen example, we kind of want those flaps to kind of just rotate or just shake a little bit. Like, here's our example, and if you watch, yeah, there we go. Now you'll notice that in this example, the box kind of shakes around as well. We're not going to worry about the box. We're just going to get these flaps to kind of rotate a little bit. So the idea is that they're going to be kind of pinned up here at the top, and then the box or the flap is going to kind of rotate about that origin point. Now to get started, I think that we should just focus on getting these 2 flaps, or maybe even just 1 flap on the screen, and position it properly on the box. Once we get the flap put together, then we can worry about actually animating it. So let's get to it. I'm going to flip back over to my code editor, and then inside of here, I'm going to go to the very bottom of our class, and I'll make a new method that's going to return a widget, and I'll call this thing build left flap, like so. Now to make the actual flap itself, we're going to use a very similar strategy for what we did for the container, or excuse me, for the box. So we're going to make a container with some set height and width, and we're going to give it a color of brown. So from my build left flap method, I'm going to return container. I'm going to give it a height, and this time we're not going to do a height of 200 or a width of 200 because of course we want these things to be kind of long and thin. So instead I'm going to give this a height of 10 pixels, or 10.0 as a double, and a width of 125 pixels, like so. And then for right now, I'm going to give this a ugly color. I'll give it a colors of red. And the reason that I'm doing this is that as we first get this flap onto the screen, I want to be able to easily tell the difference between the brown box right here and this left flap, which is why I'm going to give it a color of red, just so I can easily see where it's being positioned on the screen. Okay, so there's our build left flap widget method. Now I'm going to go back up to my build method towards the top. Here's the build method. Here's where we put our stack together. So this is just going to be another element that gets added onto our stack. So on the stack, I'm going to add in build left flap, like so. And then we'll do our refresh, as you might guess, and we're just going to make sure that this thing shows up on the screen. Okay, so that looks pretty reasonable for right now. Now you'll notice that this thing has kind of already, it's already being presented at the top left. So this being the left flap, we don't really have to move this thing around terribly much. I kind of feel like it's at a reasonable spot right now. And if anything, we kind of just need to like almost rotate it out so it kind of hangs down to the bottom left over here. So let's take a quick pause. We'll come back to the next section and we'll start to think about how we can get this thing to kind of rotate out to the left-hand side. So quick break and I'll see you in just a minute. In the last section, we got our left-hand flap to appear on the screen. Now you'll notice that it is appearing on the top left corner of our container, the container being the brown box right here. And so just as a quick review, I want you to think about why that red line is appearing on the top left. Remember, we just put the build left flap method inside of our stack, up inside the build method. So here's our stack, and here's where we put build left flap. Whenever we add something to a stack, by default, it shows up at the top left corner of the bounds of the stack. And so that's why we are seeing the flap up here on the top left-hand side. It's because that is the default location for anything we add to a stack. Okay, so it's great that we can get the flap on there, but of course, we want to actually get our flap kind of rotated out around the corner of that box or that container. So in this section, we're going to take a look at some documentation and get a better idea of how we can arbitrarily rotate widgets on the screen. Now we're going to be doing a little bit of reading of documentation. So I'm going to pull open my documentation again. I'm at docs.flutter.io as a quick reminder. And then once over here, I'm going to do a search for a class called transform. So here's transform class. The transform class can be used to essentially move, rotate, or scale different widgets that you and I create, just like the container that we just made for this red flap right here. Now, if you scroll down a little bit, don't go to the constructor section just yet, but inside the See Also section, you'll notice that the first item listed under See Also is another class called rotated box. So we can rotate elements using either of these classes. We can rotate a widget either by using the transform class or by using this rotated box. Really quickly, I want to tell you about what the difference is between these two classes and give you a better idea of when you might use one or the other. So the difference between the transform class and the rotated box class all comes down to when the transform or when the rotation is applied. So in this diagram, on the left-hand side, we've got essentially a kind of column layout widget of sorts that's showing widget 1, 2, and 3. And so this would be widgets 1, 2, and 3 without any rotation being applied. Now, when we use a rotated box to rotate a widget, you'll notice that in the documentation back over here for rotated box, and even if we go to that page for rotated box, it specifically says that it transforms or rotates an element just prior to layout. So essentially, when we use a rotated box, the widget that we're trying to rotate, in this case widget 2, is going to be rotated, and then the layout of our entire screen is going to be done with our widget in that rotated state. So now if we were making a column right here, widget 2 would kind of trick the layout engine or trick Flutter into thinking that it needs this amount of height to show up on the screen correctly. But in the case of using transform rotate, so the transform class back over here, the transformation is done after the layout occurs. So essentially our layout would be done, and Flutter would be kind of tricked into thinking that we want to lay out widget 1, 2, and 3 inside of a column like this, and so it would allocate just enough space to show widget 2 right here. But then after that layout is done, then the transform class would kick in and it would attempt to rotate widget 2. However, at this point in time, it's too late to attempt to give widget 2 its appropriate amount of space, and so it would appear to kind of overlap widget number 3. So again, that's the big difference between rotated box and transform rotate. It all comes down to when the rotation is applied. Now, in our particular case, we are not trying to overlap anything here. In addition, we are going to be using this flap as a positioned element inside of our stack. And so the flap that we're going to be using is not really going to conflict or try to compete for space on the screen against any other widget. So in our case, we can safely use either the transform class or the rotated box. For you and me, in this particular case, it really just doesn't matter. Since it doesn't matter, I'm just going to arbitrarily say that we're going to use the transform class because I think it's a little bit more interesting. Okay, so with that in mind, I'm going to now scroll down to my constructors. So on the constructors down here, you'll notice that there is a default constructor named transform. The default constructor of transform gives us total control over how we adjust a widget. So if we want to, in one step, move, rotate, and scale a widget, we could use this transform constructor right here. As shortcuts, we also get access to 3 named constructors, and each of these do exactly what they say. Transform.rotate allows us to rotate a widget. Transform.scale allows us to scale a widget, and just to be clear, scaling a widget would be like, essentially making it bigger, like scaling it up like that. And then finally, a translation will move a widget around the screen. So that's very similar to that position class that we looked at just a little bit ago. A translation would essentially take widget 2 right here and kind of move it around. Now again, if you want to do all 3 of these steps at the same time, you can use this default transform constructor instead, but that's definitely a lot more complicated than what we need. In our case, without a doubt, we just need to rotate the thing. So I'm going to look at the documentation for this name constructor. Okay, so here's rotate. To this constructor, we're going to pass in the widget that we want to rotate, and then the only other required parameter is going to be the angle by which we want to apply this rotation. So going into all this rotation stuff is just a little bit complicated. Let's take a quick pause. We'll come back and we'll talk a little bit about exactly what this angle name parameter right here does. So quick pause, and I'll see you in just a minute. In the last section, we started talking about the transform.rotate constructor and how we're going to use it to rotate this little red flap right here. Quick reminder, this red box is going to eventually end up as brown. Right now we just have it as red to make it easier to see on the screen. Okay, so let's talk about how we use this rotate constructor. So we're going to call transform.rotate, and we're going to pass in the child widget that we want to have be rotated. We can kind of imagine that the transform.rotate widget is then going to find the very center point of our widget. So you can see on these axes right here, I'm trying to indicate the very center point of this rectangle, and then it's going to apply a rotation to that in the clockwise direction. So kind of around in this direction, like so. Now the amount of rotation that is applied is specified by this required parameter of angle right here. The angle parameter is not going to be measured in terms of degrees. So we do not specify rotations as like, hey, rotate this 90 degrees for me, or 180 degrees, or even 360 degrees. Instead, we specify rotations in terms of radians. And so if you remember algebra or geometry, and you remember talking about radians, this is where radians come into play. So if you're not familiar with radians, totally fine. Quick review on how we do rotations that are measured in radians. On the screen right here, I've got our red box, and on every case, I've drawn out the center point of the red box, and then I put on a little green box at the very end, just so you can kind of get an idea of the direction in which the rotation is being done. If we apply a rotation of 0 radians to our red box, then that means that we are doing no rotation whatsoever. if we do a rotation of 3.14 divided by 2, so that is pi, like pi radians, or pi divided by 2 radians, that is equivalent to a 90-degree rotation. And so we take the green box and we can imagine that this thing kind of gets rotated like so, 90 degrees. If we do a rotation of 3.14, or essentially pi radians, then that is equal to a full 180-degree rotation. And so we would go all the way around in the clockwise direction, like so. And then finally, if we wanted to do a 270-degree rotation, that would be 1.5 times pi radians, which we could also express as 3 times 3.14 divided by 2. Okay, so if you don't remember paying attention to radians back in school, yeah, again, this is where it comes up, but don't worry about it. Our rotations are going to be pretty straightforward. So now that we've got a better idea of how these rotations are done, let's use the transform.rotate constructor to rotate our left flap. So back inside of my code editor, I'll find the build left flap method, and then inside there, I'm going to return transform.rotate. I'm going to specify the widget that we want to rotate, which is going to be our container. So I'm going to highlight that thing. I'm going to cut it, and then I will paste it in as the child property. And then I'm going to clean up the return keyword. And don't forget to get a comma at the end there. Then we also are required to specify the number of radians that we want to rotate this thing by. So for right now, let's just try to rotate this by 90 radians, or excuse me, 90 degrees, which would be an angle of essentially 3.14 divided by 2.0. That is equivalent to a 90-degree rotation. Now, 3.14 right here, again, that is pi, but really it's a very rough approximation on my part of what pi is. If you want to use the actual real value of pi, we can always import the Dart math library at the very top of the file, and inside of the math library that is a part of the Dart standard library, one of the constants that we get access to is pi. So if we want to use a more exact value for pi, we can alwa's import this and make use of that. Let's do so right now just to see the full example. So at the very top of this file, I will import Dart math. And then back down here where we specify our angle, rather than using this very rough approximation, I'll instead do math.pi and then still divided by 2. Oops, my mistake, not math.pi, just pi, like so. So just pi divided by 2.0. Okay, so let's give this a shot. So I'll do my refresh. Again, I'm going to expect this thing to be rotated 90 degrees about the center point of that flap. And so there's our refresh, and clearly, yep, it got rotated about the center point. Now, it's great that we are able to rotate about the center point, but if you look back to what you and I are trying to do, we essentially are starting off with a little container or rectangle that starts off like this right here. I don't really want to have to try to like rotate this thing 90 degrees or I don't know, some additional amount like so, and then try to like move it down. I think that there's probably an easier way to do this. Personally, I think that would be really nice is if we could instead rotate about this like top left corner up here. If we could rotate about that corner, then all we would really have to do is apply the rotation about that top left corner, and then it would eventually leave us with something that looks like that. I can't rotate about that top left corner inside this editor. Hopefully you kind of get an idea of what I'm getting at here. So let's take another quick pause. When we come back to the next section, we'll talk about how we can change the point about which we rotate some given widget. So quick break, and I'll see you in just a minute. In the last section, we spoke about how the transform.rotate widget applies a rotation to the very center of the thing that we're trying to rotate. Rather than applying a rotation to the center, you and I would probably be very well served to try to rotate about the top left point instead. So we need to figure out a way to specify that we want to do the rotation about this point up here, because it's just going to make laying out our flap over here a little bit more straightforward. So to specify the point of rotation, we're going to take another look at our constructor. So I'm looking again at my transform.rotate constructor. one of the name parameters on here is the alignment property. By default, alignment has a value of alignment.center. And so you probably get an idea of where we're going with this. Rather than using the default value of alignment.center, we can specify a different default rotation point for our widget by passing in a different alignment value. Now, to get a better sense of what value you and I need to pass in, we're going to look up the documentation for the alignment class. So up on the search bar up here, I'm going to look for alignment, and I'm going to find the alignment class. Then inside of here, we're going to scroll down towards the very bottom and find the section that is called constants. Right here. So here's constants. So inside the alignment class, there are a couple of different constant properties that we can reference to specify what we want our rotation point to be. By default, as we just saw, we get the center point specified. We could also say use the bottom center, which would be like right here, this bottom center edge. Or if I actually use the little thingamajig. Come on, give it to me. Okay, well, you get the idea. That point right there, bottom center. We could also do the center left or the center right, or what you and I really want are top left corner. So the top left corner up here is going to be the origin or the point of our rotation. So we're going to flip back over to our code editor. I'm going to find transform.rotate. I'm going to add on a name parameter of alignment. And to that thing, I'm going to provide alignment dot top left, like so. So let's now save this. To make the rotation a little bit easier to see, or to kind of get a better sense of what point we are rotating about, I'm going to very temporarily change the height of our container. Again, I'm doing this just to make it easier to see that, in fact, we are rotating about the top left corner. So I'm going to go up to a height of 40. I'll save this, and then we'll do a quick refresh and test it out. Okay, so back over here, there we go. So we still have a 90-degree rotation, but now rather than rotating about the center point, we are rotating about the top left, which is much closer to what you and I want. So this is looking a little bit better, but we're still at a straight 90 degrees right here, when in reality, we probably want something just a little bit greater than 90 degrees, so it kind of angles off to the bottom left-hand corner. So let's take another quick pause. We'll come back to the next section, and we'll put in a different rotation angle to get something that looks a little bit closer to this. So I'll see you in just a minute. In the last section, we managed to change the point of rotation of our little flap over here, but it's still going straight down, when in reality, we definitely want it to kind of angle out to the left-hand side. So to change the angle of rotation, I'm going to go back over to my transform.rotate method. I'll find where we specify the angle, and I'm going to slightly change the angle here. So rather than doing pi divided by 2, I'm going to change this to pi times 0.6 like so. So before we were taking 50% of pi, now we're essentially taking 60% instead. And so that's going to give us just a little bit greater rotation about this point right here, and it's going to give us a little bit of separation between the box and the flap itself. So let's do a quick refresh and see how that looks. Okay, so, well, we got a little bit more space there, but now you can see how these things are connected by like just the smallest little point. So that doesn't look horribly realistic. Let's try making the flap itself a little bit more skinny and see if that helps at all. So rather than doing that height of 40, I'm going to try reverting this back to what we had before, which was a height value of 10 pixels. So I'll save that, I'll do another refresh, and we'll see what that looks like. All right, so here's the refresh. All right, well, that looks a little bit better, but still, it kind of looks like the flap and the box are connected by just like the tiniest little connection right there. So here's what I'm thinking. I'm thinking that in addition to applying a rotation to that container, I think it would be kind of nice if we decided to also apply a little bit of a positioned element to it as well to kind of scoot it in just a little bit like so. That's just going to make it appear that the flap and the box are a little bit more connected. So let's try adding in a positioned element around our rotation as well. And we'll see what that looks like. So now, inside of build left flap, rather than just returning the rotation, I'm going to instead return a positioned element. Oh, did I get my spelling right there? Positioned. Yeah, I think so. And then to this thing, remember, just like before, we are going to give it a child, and then we can specify a top, right, and a left. So on positioned, to get this thing to kind of scoot over or kind of scoot to the left a little bit, essentially to get this flap right here kind of over, I said to the left, excuse me, to get over to the right, we're going to specify a left offset. So if we put in here a left property of something like, say, 3.0, that's going to find the left edge of our stacked container, and then it's going to give us like 3 pixels or so from that left edge to where our container first begins. So that would be kind of the effect of a left of 3. We're essentially saying put 3 pixels between the left-hand side of the stack and the start of our little widget. So besides left, I'm also going to specify a child, and to the child, we're going to put in the transform rotate block that we had just created. So I'm going to take that entire block, I'm going to cut the entire thing, and I'll paste it in as the child. Now don't forget to get a comma at the end of the transform.rotate, and don't forget to return or clean up the return statement at the bottom as well. Okay, let's try it again. I know this is kind of a nitpicky thing, but I just want it to look pretty good. Okay, so now it's a little bit more connected. Now I'm kind of happy with it right there. I mostly just wanted to show you how you could kind of scoot the thing in a little bit to connect it a little bit more and play around with it. So I'm happy with where it is right now. I'm not going to make you watch me fiddle around with it anymore, but if you want to kind of mess around with this thing a little bit, certainly feel free to do so. Keep in mind, you can also specify a top property here as well, and that will cause this thing to kind of like move down a little bit, which might be useful in getting the thing to kind of like, really appear to be part of the box. But again, I'll leave that up to you. Okay, so I think that overall the left flap is looking pretty good. The last thing I want to do is change the color of the flap from a red color over to a brown as well, so it more closely matches the overall box. So on the color for our container, I'm going to change colors.red right here to colors.brown, like so. So then one more refresh. Do a quick test. All right, that's better. Okay, so I'm thinking this looks pretty good at this point, or at least good enough. Let's take another quick pause. When we come back in the next section, we're going to figure out how we can now attempt to get this thing to shake or kind of animate it as long as our cat is in the box. So quick break, and I'll see you in just a minute. In the last section, we got our left-hand flap positioned on the top left corner of our box. And so at present, it definitely looks like it is at a reasonable location. So now we need to turn our focus a little bit and start thinking about how we're going to animate the flap. Remember, the overall goal here is to make sure that when the cat is inside the box, we want to see that flap kind of wiggle back and forth just a little bit, as you see over in this existing animation. Yeah, just like that right there. So essentially, we want to pivot that little flap about its connection to the box on the top left-hand side. And so it's really hard for me to show you that with the tools I have inside of this diagram right here, or this diagramming tool. But essentially, I want this edge to kind of like wiggle back and forth. Oops. And I want the top right-hand side to just stay pinned right there. Now, the actual movement is very similar to all the stuff that we just put together around our transform rotation right here. And so what we really want to do is somehow manipulate this angle property. This is the value that we are going to want to change over time. Because if we change this from like pi times 0.6 down to pi times 0.4 or pi times 1 or whatever it is, that's going to cause the entire flap to appear to rotate in its current location. So doing another animation here is going to be very similar to the animation we already put together. We're going to have another animation controller specifically created to manage that left-hand flap. We're going to set up another tween to specify the different values of rotation that we want to apply to that angle. and then we're going to set up another curved animation that describes the rate at which that value is going to change, and we're going to assign all that to an instance of an animation. And remember, those animation objects are essentially just wrapping a value that is going to change over time. So a lot of the code we're going to write here, very similar to what we already put together, just a couple of small customizations to make things a little bit more appropriate for the box animation. So for example, we probably will not want to animate or tween from -35 to -80. We'll probably want to have some different range of values. So let's get started right now. Inside of my home state class, I'm going to add on 2 new instance variables. I'm going to call the first one an animation that's going to contain a value of double, because again, we are changing that angle property, and the angle property accepts a double argument or a double value. And then I'll call this thing box animation. I'm calling it box animation because at the end of the day, we're actually going to use this animation object for the flaps on both the left side and the right hand side. So that's why we're not going to call it something like, flap animation. I'm calling it box animation specifically because it's tied to the box. I'll then also make an animation controller called box controller. Then inside of our init state method, we're going to set up the box animation and the box controller very similar to what we already did for all the cat stuff. So I'll say that, how about right underneath our init state call, I'm going to assign a value to box controller. That's going to be a new instance of an animation controller. And then we're going to just kind of guess at the duration for this thing again. Remember, when we first set up the cat controller right here, we gave it a duration of 2 seconds, and then we later adjusted that to 200 milliseconds. And so I'm going to, again, just kind of guess at a duration of seconds of 2, like so. Good place to get started, and then once we get the animation on the screen, we can kind of play around with the duration a little bit more. Then we're also going to pass in the name parameter of vsync, which is going to be this. And remember, the entire idea behind this name parameter right here is that we got that ticker provider mixin on our class. And so this mixin right here is essentially an object that kind of pokes at the animation controller 60 times a second, so 60 frames per second, and tells the animation controller, hey, it's time for you to update to a new value. Then right underneath that, we're going to define our box animation. So I'll say my box animation is going to be a tween. And then we're going to have a begin value here. Remember that we are animating the angle, and that angle is supposed to be a radian value. And so reasonable values for radians kind of span between like 0 and 3.14 or pi, or maybe 2 times pi. So maybe to get started, we could have a tween value here of something that ranges from 0.0, maybe to an endpoint of like 3.14, or essentially, again, it's pi. So that's a good place to get started. And then once we kind of come back and get a sense of what range of values or range of rotation we want to have in there, we can adjust these a little bit. Then on the tween, I'm going to call .animate, and into the animate function, I'm going to pass in a new curved animation object. Remember, just like our cat animation down here, curved animation is going to describe the rate at which our value is going to change. So I'll pass in curved animation. It's going to have a parent of the box controller, and then it's going to have a curve, and the curve property right here is what actually describes the rate at which this value changes. We'll start off with a curves.linear, like so. And so that indicates that we want just a very constant, consistent rate of change of our animated value. Again, once we get the animation playing, we can then come back to this curve and play around with it a little bit and decide whether or not a linear change is appropriate. Okay, quick reminder, you can always mouse over this thing if you're in VS Code, and you'll see the chart right here that will tell you the rate at which the value is going to change. So linear specifically means constant change between the values of 0 to 3.14 over the span of 2 seconds. All right, so I think that's a good place to get started. I'm going to put a semicolon on there, and I'll save the file. When I do, again, we see a little bit of code jump right there, which is totally fine. Now, one thing I want to remind you about, remember at some point in time, we have to specifically call forward on the box controller to tell it to start to animate forward or to actually progress the animation. The other thing we have to do is take the box animation object, which is the value that's going to change over time, and wire that up to an animation builder. So 2 steps to get to still. Let's take a quick pause right here, and we'll take care of those 2 steps in the next section. In the last section, we put together our initial take on the animation controller for the box and the animation for it as well. Let's now flip down back to the left flap build function, and we're going to wire up this new animation value with an animation builder. So I'm going to go back down to the very bottom of this file where we have build left flap right here. So remember how we wire up an animation to an actual widget. We're going to use an animated builder, just as we did up inside of build cat animation right here. The animated builder receives the animation value, so this is the thing that is going to change over time, and then every time this value changes, the builder function gets executed again. And then remember, for performance reasons, we also have the ability to create our component or our widget out here outside of the builder so that we don't have to recreate this cat, in this case it was a cat, every single time. And so we might want to take that performance benefit or that performance gain around this time as well by creating the flap itself outside of the builder or pass it as an argument to the builder. So down inside of build left flap down here, we have positioned, which is attempting to position the element. We have the transform, and inside the transform is the container. So the value that we want to change here is on the transform.rotate widget. It's specifically angle right here. This is the thing that we're going to want to change over time. So I think that transform.rotate right here can probably be placed inside the animated builder function, but we might want to attempt to create the container ahead of time. And so we have kind of like a cached version of the container that we're not going to recreate over and over and over again. So let's give this a shot. And this is going to be kind of a nasty little refactor because we're going to kind of tear apart all 3 of these widgets. So I'm going to give myself a little bit of space up here to start, and we're going to add in a little bit of code as we go. So the first thing I'm going to put inside of here, I'm going to return my animated builder. And on my animated builder, I'm going to provide the animation, which will be my box animation. That's the value we just created 2 seconds ago. I'm going to define the child that we're going to create one time and essentially cache that widget to be used again in the future. That's going to be the container right here. So I'm going to highlight the container, and we're going to just reuse this code. So I'm going to do a cut, and then to the child property right here, I'll do a paste. Then after that, I will define my builder function, which is going to take my build context, and it's also going to take the child widget that we had just defined. So remember right here, this child argument is going to be the child we just passed in of container. So now inside of the builder is where we're going to create our transform rotate, and we're going to use our animated value to assign a property to angle. So rather than having angle be fixed at pi times 0.6, we're going to say that the value for the angle is going to come from our box animation value. So inside the builder, I'm going to return transform.rotate. Rotate. My child is going to be the child that gets passed into the builder, so that is essentially this container right here. I'm going to make sure I specify the alignment. So I'll say alignment is alignment top left. And then we're going to define the angle as well. And again, the angle is going to be our box animation value. Box animation is going to be tweened, ranging from 0.0 up to 3.14 right now. And so we're going to see this thing kind of like waggle back and forth. Probably it's going to wiggle a little bit too much, but like I said, we'll come back and kind of do a little tweak or two on the box animation. Now, when we pass in box animation, it's not just the box animation. Remember, this is a class that actually wraps or contains the value we actually care about. So I'm going to reference the .value property on there, and that's what we're going to actually pass in. Okay, so that takes care of our transform rotation. Now, the last thing we have to make sure that we apply to this is the original positioned element. And so I think that we can just wrap the entire animated builder with positioned, so that the entire animated builder and everything inside of it will be shifted by those 3 or so pixels off the left-hand edge of our stack widget. So up here at the top, this is going to be a nasty little bit because we're going to have to make sure we get all the indentation just right. So we'll say positioned. That's going to have a child of everything that we just put together. So I'm going to take the animated builder, but I'm not going to include the semicolon right there. I'm going to cut that entire thing and paste it into the child. Then at the ending parenthesis for the animated builder that we just pasted in, I'll make sure that I get a comma in there. I'll get a semicolon on the closing parenthesis for the positioned widget. And then as another name property to positioned, I'll make sure that I specify a left of 3.0, like so. Okay, so now a little bit of cleanup. I'm going to delete all the leftover stuff that we have down here. And then I'm going to save the file to get a little bit of automatic formatting to kick in. It looks like I forgot a comma after my builder function, so I'm going to add that in really quickly. Save again, and I end up with something that looks like so. Okay, so that looks pretty good. Let's take another quick pause. Remember, we still have to make sure that we tell our box controller to start the animation forward at some point in time. So we'll take care of that in the next section and then do a test inside of our emulator. So quick break, and I'll see you in just a minute. In the last section, we wired up an animated builder to our build left flap method. We're now going to make sure that at some point in time, we actually start the animation and play it forward so it plays out on the screen of our device. So to do so, I'm going to go back up to my init state method. So here's init state right here. Here's where we created the box controller. And then right underneath that is where we created the box animation itself. So after creating the box controller and its animation, I'll then start the animation running by calling box controller.forward, like so. I'll save this, and then we'll do a quick refresh of our terminal, and we'll test this thing out inside of our emulator. Okay, so there we go. And as you can see, the flap right here swings from kind of inwards, like towards this direction right here, and it goes all the way out to the outside edge. Now, definitely the range of the angle here is not that great. In other words, I think that the animation is playing way too much, or the flap is swinging way too far. Now that's totally fine. We can always adjust our tween values right here and begin and end with some different angle. But what seems like a little bit more important right now is the fact that the animation only plays one time. So remember, we want this little flap to wiggle back and forth until the cat comes out of the box. So as long as the cat is in the box, this thing should be going back and forth, back and forth. So to do so, we can add an event listener onto our box animation object right here. We can watch that box animation, and we can say that any time the box animation state changes, so anytime its status goes to completed or dismissed or any of those other different statuses that we were working with before, then we can attempt to automatically restart the animation. So to do so, right above where we just called box controller.forward, I'll call box animation.add status listener, like so. This is a function that takes a callback function inside, so I'm going to add in a callback function right here, and then this callback function will be called with the updated status of the animation. The status argument right here is of type animation status. So like we just said, identical to the animation status objects that we were dealing with previously. Remember, animation status has a couple of different constants assigned to it that describes the current state of the animation. So now inside of this add status listener function, we can look at the value of the status, and we can say if that thing is equal to animation status dot completed. So if the thing is all done and it's ran the entire animation, then we can look at the box controller and tell it to attempt to repeat or replay the animation again. So we'll say box controller dot repeat, like so. So the repeat method is one that we've not seen before. Very similar nature to the forward method and the reverse method down here as well. So as you might guess, all the repeat method is going to do is reset our animation value back to its beginning value and play it to the end of 3.14 again. So let's save this again and give it another quick test. So I'll do my refresh, I'll open up my emulator, and we're going to expect to see this thing to just continuously play again and again and again. Okay, so that looks pretty good. Well, it doesn't look that good, but it's definitely progress forward. So let's come back to the next section, and we're going to do a little bit of work on this thing to make the animation's range, or kind of the wiggle right there, a little bit more predictable. And we'll also make sure that it's not quite having such a jarring reset effect. So quick break, and I'll see you in just a minute. We've now got our flap swinging from all the way inside, all the way out to the out edge, and then it resets and plays again. Now, this definitely has kind of the right behavior, but the range of the animation is way, way off. So I took a little bit of liberty here, and I played around with the tween values to test out the range of the angle that we want to play around with, and I found some different angles that might be a good place to begin and end the animation at. Now, to put in the code for this, I do have to ask you to make sure that you have imported the math module up here at the top, because we are going to reference the pi constant that's a part of the math module. So make sure you have this import statement up here. Then, down inside of our tween, rather than going from 0 radians to 3.14, I'm going to instead begin with a value of pi times 0.6. Let's do 0.6 just to be consistent. And then we're going to animate all the way to pi times 0.65. So now we're going to go from 60% of pi to 65% of pi. Remember, these are radian values eventually when they get applied to our angle or our rotation transform. So a rotation of about 60% is essentially going to take us from like about right here to right here, like back and forth, like just about that much or so. So if we now save this and do a quick test, and I'll pull my emulator back up. So as soon as that refresh kicks in, we'll see that it's got a much more constrained range of animation. All right, come on, where's the refresh? There we go. Okay, so definitely much more constrained range of animation. However, two issues with this now. It's very clear that the animation is playing too slowly, so I think that we now need to play around with our duration a little bit. And the other thing I want to point out here is that even though it seemed like maybe using this repeat right here to restart the animation was a good idea, all that's really doing for us is it's causing the entire flap to like jump back to its starting location. So maybe that wasn't the best call on my part. Maybe instead we should use the restart logic that we had used before, where we take our controller, we watch for it to be completed, and when it gets completed, we'll reverse it, and then when it goes back to its initial state, which is reflected by the dismiss property, we'll tell it to go forward again. So I think we should do that rather than just always assuming that we want to repeat the animation from scratch again. Let's first take care of our duration. So up here on the box controller, I'm going to find the duration, and rather than doing 2 seconds, which is clearly a little bit too slow, I'll give it a milliseconds, and let's try out like 300 milliseconds or so. So that's 0.3 seconds, definitely much faster than this current animation right here. And then we'll also do a little bit of brush up on the add status listener. So we're now going to say that if we look at the status and it is completed, rather than repeating the animation, I want to reverse it to go back towards the initial state. And then we'll also say, else if the status is at animation status.dismissed, so back at its initial state, then I want to start playing it forward again. So we'll say box controller dot forward, like so. Okay, so another quick test. Hopefully the restart won't take as long as the last time of 17 seconds. That was definitely a little bit too long. So let's let this thing kick in. There we go. Okay, now that's definitely much more reasonable. Now on my emulator right here, the animation is a little bit janky. In other words, it's not super smooth. Chances are that's because I'm running video recording software and the emulator and a lot of stuff on my computer at the same time. So hopefully your animation that you're seeing looks a little bit smoother than mine. So this right here definitely looks way closer to what we had wanted. So I think we'll take another quick pause right here, come back to the next section, and we'll start putting together our animation for the flap on the other side of the box as well. So another quick break, and I'll see you in just a minute. In the last section, we put together everything we needed for the left flap animation. The range and duration and speed of it is now looking pretty good. So we're going to take just about everything that we just did for this left flap and now apply it to the right-hand side as well. So to get started, I'm going to first find my build method. Here's build. Here's where we created our stack of all these different widgets that we're trying to animate on the screen. And we had called a build left flap method right here. So I'm going to add another method call underneath this, and I'll say build right flap. So we're going to essentially take everything we just did for the left flap and repeat it all for the right flap as well, with the exception of the box animation stuff. So we can just reuse this exact same box animation and the box controller as well for the right flap. No reason to create a second animation. Once we create an animation value, we can reuse it inside of our application on as many different widgets as we want. So I'm going to go back down to the bottom of the file, and I will find my build left flap method. Here it is right here. So I'm just going to copy the entire method, and I'm going to paste it right underneath it. So here's my copy of build left flap right here, and I'm going to rename this copy build right flap instead. So now inside of here, we're just going to change a handful of different properties. First off, I'm going to find positioned, and rather than having an offset of 3 pixels from the left edge, I'm going to instead want to have an offset of 3 pixels from the right edge. So now we're going to have something, let's go back over here and actually kind of diagram it out. Okay, so we're going to want to have our right flap 3 pixels off the right edge. So by putting in 3 of right, it's going to essentially pull us over here towards the right-hand side, and we're going to have a 3 pixel gap right there. Then the next thing we need to do is to make sure that we also set our transform point. Just like we did over here, we had said that rather than using a transform location of the center point of the little container, we had wanted to use the top left instead. And so in this case, we're going to do something very similar, but we're going to rotate about this top right edge rather than the top left. So back over here, I'm going to find where we had set up that alignment property. Here it is right here on transform.rotate. So rather than setting our rotation point around the top left, I'm going to do my top right instead. And then I think maybe the last thing we have to do is do a little bit of an adjustment to our angle. Let's do a quick break. We'll come back to the next section and we'll figure out how we're going to adjust the angle right here. Because at present, if we just use the exact same animation value that we're using for the left flap, then we're going to end up with something that also is attempting to kind of like rotate it to the bottom left like so, which is probably not what we want. So another quick pause, and we'll come back to the next section and wrap up this right flap. In the last section, we started putting together our build right flap method. We copy pasted just about all of our code over from the build left flap. We had updated the right, and we also updated our alignment right here as well. So last thing we have to do is take care of our angle. So we're not going to want to transform by the same angle that we were using for the left flap because its orientation is going to be a little bit different. To give you a better idea of why we don't want to use exactly the same angle, I went ahead and refreshed my emulator. So if you refresh with the code that we have right now and use the exact same value for the angle transform as our left one, this is what you end up with. So definitely not quite what we're looking for. So at present, when our flap on the right-hand side gets drawn, you can kind of imagine that it starts right here and then it spans off to the left-hand side. And so we're essentially taking that flap and rotating about its point right here, its top right corner, and we're essentially pulling it up 0.6 to 0.65 radians. So rather than pulling it up, we just want to pull it the exact opposite direction. We want to pull it down 0.6 to 0.65 radians. So in order to rotate in the opposite direction, all we have to do is use a angle that is the negative of the box animation value. So that's going to apply the rotation in the opposite direction. So if I now save this and do my refresh, and if we wait just a second or two as usual, it seems like it's a little bit slower today than it has previously. We'll give it a second or two to kick in, and then we'll see that it is appearing on the bottom right-hand side, like so. Okay, much better. Okay, so that's looking pretty good. Now, I definitely like the flap as it is right here. Just one thing I want to throw out there, if you want to add a little bit more flavor to the animation, one thing you could always do is go back up to where we create the animation curve for the box. Okay, so inside of our init state method, here's the box animation. Here's where we put together our curved animation. So rather than using a linear rate of change, which really makes these things just go in and out at the exact same rate, we could use a different curve. So you might try something like ease in out. So if you mouse over that, you'll see the rate at which the animation plays. So it starts off kind of slow, it gets faster, and then it ends kind of slow as well. So again, these curves just give your animation a little bit more realism or a little bit more play, I suppose. So I'll do a restart, but we won't sit around and wait for it to go. We'll go and check it in a second. More importantly, the other thing I want to mention here is that we still need to make sure that anytime the cat comes out of the box, we stop those flaps playing. So putting this together won't be that bad. I'm going to scroll down to our onTap method right here. So like I just said 2 seconds ago, anytime the cat comes out of the box, we need to stop the flap animation. So to stop the flap animation, we can reference the box controller inside this thing. And we can say box controller .stop. It's just that easy. So anytime the user taps on the box, look at the box controller, tell it to stop animating the value. And that's going to cause our flaps to freeze in place. So I'll do another quick refresh and we'll test that out in just a second. But since it's going to take a minute or two to do the refresh, I want to very quickly mention that right here when we stop the box controller, if we then tap on the cat again, then chances are the box controller is not going to magically start back up. So we need to make sure that anytime we tap on the box, we either stop it, and then the second time the user taps on it again, we want to start it up again. So essentially, we want to kind of toggle the state of this cat. So let's take another quick pause, come back to the next section, and we'll make sure that we toggle whether or not the box controller is running the animation in the next section. In the last section, we said that we wanted to make sure that the flaps stop animating anytime a user taps on the box, so we added boxController.stop to our onTap method. However, now we have introduced a way for the animation to stop, but there's no way for the animation to start back up again. So in reality, if you really think about how our animation works, if the cat is in the box, we want the flaps to be playing. If it's out, we want the flaps to stop. So then once the cat goes back into the box, we probably want the flaps to start up again. So we can really just make use of the same if statement structure that we already have inside of onTap. So rather than just always calling boxController.stop right here, no matter what, I'm going to say that if the animation is completed, so if the cat controller is complete and it's outside the box and it's about to go back inside the box, that means that I want to start the box controller back up. So I'm going to call forward, like so, to play it forward. Then in the case that the cat is going back into, or coming out of the box, excuse me, if the cat is coming out of the box and we just start up the cat right here, that is the case in which we would probably want to stop the box controller. So inside this case, I'll add box controller.stop. And then we do not need this initial stop right here anymore. So now anytime a user taps on the thing, we're going to look at the cat and then toggle the two controllers appropriately. All right, so I'm going to do another refresh. We'll let that kick in. One quick thing I want to mention here, you'll notice that with our box controller, we're calling stop, but when we're dealing with the cat controller, we're calling reverse. So that's all because anytime that we are kind of dealing with our cat in any way, we only want to allow it to change its state or to kind of reverse direction if it has already completed its animation. If a user taps on the thing again, we had said that we don't want to like change the direction of the cat mid-transition. So that's why in one case with one controller, we're using reverse, and in the other case with the box controller, we're calling stop. Okay, so we'll test this out again. So flaps are playing, cat is inside. I can click on the cat comes out of the box, flaps start and stares at us. And then we tap it again and flaps start animating again. Awesome. So that is pretty much it. That is animation in a nutshell. So take another quick pause right here, come back to the next section, and we'll do a quick review on everything that we learned inside this app. We just finished up our cat animation. Before we move on to our next application, there's a couple of quick things I want to review. So in all this stuff with animation, the big overarching idea to keep in mind is that when we start thinking about an animation, we need to start to isolate or think about the different properties assigned to our widgets that need to change over time. Again, when we put together our animation, there was not some magic widget that said, oh yeah, try to like rotate this flap for me automatically over the span of 2 seconds. Instead, we used a widget that did a kind of one-time rotation. We then created an animated value and assigned that animated value to that widget. So then anytime the animation changed through our animated builder right here, we would rebuild the rotation and use the new value of the animation. So the big idea here is we need to think about what value is going to change around our animation, and then we will create an animation object to represent that value. We then use that animation object to apply some changing property to a widget. The other thing I want to mention very quickly is when we put together our animation, we did not only create the animation, we also created a tween object instead. We can use a tween to specify the range of values that we want our animated value to play between. We then controlled the state of that animation through the use of an animation controller. So the animation controller was all about somehow starting, stopping, or restarting the animation at some point in time. Now, last thing I want to remind you about is that we can listen to status changes on an individual animation. So we can say that anytime some event occurs to an animation, we can add on a callback function and attempt to somehow work with the animation in some fashion. You're going to most frequently use these status listeners anytime that you want to get a notification of when the animation is complete, like if you want to play a little success animation for when a user signs up to your application. You want to have the entire animation play and then do something else. So that'd be a good place to use a status listener. The other time that you might use a status listener is if you want to chain together multiple animations, which is kind of what you and I did in this case to a degree. We kind of wanted to make sure that anytime our animation status for the box was completed or dismissed, we kind of got a quick note and we chained on another leg of the animation to that. So another good time to use a status listener. All right, so that is it for animation. I hope you enjoyed this little animation. I definitely thought it was kind of cute to put together. So let's take another quick break and we'll continue in the next section.